Hello dear students, this is your science teacher, Ben, and today we will start with the second chapter, which I have given you a brief introduction to get familiar with this chapter in our last class. So without wasting time, let's start the class right away. So this is what we'll study today, acid, bases, and salts. So to study this acid, base, and salt, first we have to know the physical properties, we have to know the chemical properties, and also we have to study the different types of acid, base, and the properties. So if you remember, I have given you physical properties for acid and base in our last class. So I will not write down, but I will just recall, I'll just say it out. Acids are sour in taste, and base, they are bitter in taste, they are soapy to touch, and acid are those which give hydrogen ion in dissolving with water, and base are those which give hydroxide ion in dissolving with water. So today we'll start with different types of acids. Acid also we have different types. There are strong acids, there are weak acids. Weak acids are usually it's edible. Some example of weak acids may be citric acid. Citric acid is those which we get from lemon or orange, so those are edible. But strong acid, let's say HCl, those are dangerous. So those are used only for industrial, and we use it in the practical lab, so don't consume that. Acids, we should never play with acids, those are very harmful. Clear? Okay, so we'll start with types of acids. So before I give you a definition or any example, let's make it simple. Let's clear the concept. So strong acid and weak acid, I'll give you an example. Okay, let's take 2 glasses of water, and in let's say first glass, put 1 spoon of salt. And in the second glass, let's put 10 spoons of salt. So which one will be more saltier? The second glass. And the first glass, it will be salty, but it is just 1 spoon. But no matter, both contain salts. So the second one is more saltier. Why? Because we have lots of salt there, 10 spoons. So the same concept goes out here for the strong acid and weak acid. So let's start here, strong acids. Strong acids are those which on dissolving with water gives large amount of H plus, that is hydrogen ions, okay? Example here, I'll give you HCl. HCl, that's hydrochloric acid. If we dissolve this one, if we break this one, that means the breaking down, even if it's not 100%, maximum 99% of breaking down will happen here, and we'll get to see here hydrogen ions here. Clear? So this type is a strong acid. Now, those acids which will get on breaking down, on dissolving with water, gives us a limited amount of hydrogen ion, will be weak acids. So if you are done with this one, I'll write for the weak acids. Okay, weak acids are those which on dissolving with water give limited amount of hydrogen ion. And example for this would be, so this is also an acid, and if we look this one, this compound, it's a large compound. So to break this one will also be, would not be an easy like the HCl. HCl, it was very easy for us to break this bond, but this bond to break would be difficult because it's a large compound. And this is a very common acid. This is an acetic acid, okay? Acetic acid. And acetic acid, we get it like naturally from vinegar, okay? These are acids which we get from vinegar. CH3COOH. So if we break this one, if we dissolve this compound in water, we will get so we have this here. So we aren't able to break this one completely since it's a large compound. So we get limited amount of this one. But irrespective of this, we still get hydrogen ion. So it's an acid, but we will categorize this one under a weak acids. Clear? So we can give example acetic acid. Okay, now there are many acids which we can obtain like naturally. Clear? And these are often asked like in exam, in your objective questions or 1-mark questions. So let me give you the names of those acids which we can get it like naturally. 1. Let's write natural source. Natural source. Okay, from lemon and from lemon and from orange. Lemon and orange, they are sour in taste. If it's sour, that means they contain an acid. So from lemon and orange, we get an acid, and those acids are called as citric acid. Keep this in mind, students, citric acid. Citric acid. The acids which we get from lemon and orange are known as citric acid. Now the next thing we discussed just now, that is from vinegar. From vinegar, the acids which we get is acetic acid. Acetic acid. Acetic acid. ACETIC for our listeners. Acetic acid. Now the 4th one, sour milk. If I say sour milk, that is sour milk. So that is a curd, right? Curd. Sour milk or curd. So even in a sour milk or a curd, it contains an acid. So what is the name of that acid? So it is lactic acid, okay? LACTIC, lactic acid. Okay, from lemon and orange we have citric. From vinegar we have acetic acid. From a sour milk, that is curd, we have lactic acid. Now the next one is a common one. I'm sure you know this one, you're familiar with this. That is from tamarind. Tamarind, a local name is imli. Imli, and the acid that we get from tamarind is tartaric acid. TAR, tartaric acid. Tartaric acid. Okay? Now the next one. The next one, okay. Are you okay? So you're done with this first 2 one. I'll wrap. Okay, I'll write here. I'll write here for the 6th one. For the 6th one, I will write here. The 6th one, I'm sure you have, you have come across this plant, okay? The name of the plant is nettle, Nettle, nettle leaf. Nettle leaf. Nettle leaf. So maybe whenever like, okay, have you ever experienced this pain? Okay, you went like for a trekking and then you accidentally touch a plant. And then by just touching that plant, you got a very sharp pain. Have you ever experienced that kind of leaf? Or maybe in a forest, maybe when you were a small kid, you just went with your friends like in a forest and then you were playing and then suddenly you touch a plant and then you got a very sharp pain. Sharp, you got a, it's a very, you get irritation there, okay? Because it's a sharp pain. And what does they do? They inject you with an acid. And the name of that acid is a methanoic acid. I'll write in a bold letter, methanoic acid. So what does this leaf do? This leaf, they inject you with an acid. And the name of the acid is methanoic acid. Clear? Now, so this, from the nettle leaf, they inject you with an acid, and the same acid you will also get from an ant sting, okay? From an ant. And the local name is chimti. Okay, so I'm sure you all have gotten this as an sting. Okay, so you'll get a very sharp pain. So the same pain, they inject you a methanoic acid. So what does, to get a cure from this pain, what we have to do? Since they have injected an acid, we have to neutralize this one with a base. Okay? Acid and base, they neutralize each other. So what we can do is that we can apply a baking soda. Baking soda is a mild base. So we can rub the skin with a baking soda. That way it can help. Or maybe like if you are in a jungle and then suddenly you touch a nettle leaf and then you got a pain and then you don't have any other choice, then you can, this is a very common plant, okay, dog plant. And I'm sure you are familiar with this plant. I wish I could get that plant and I could show you, but that is not possible as of now. But just write this one and you can Google it. Okay, so dog plant, if you just rub this dog plant in your skin, then you will also get, the pain will be relieved. Clear? Okay, so these are some acids which we get naturally. So how in exam they will ask you, what kind of acid do we get from a nettle leaf? Or what kind of acid we'll get from a lemon or orange? Or what is the name of the acid that we get from sour milk? So in that way, they might ask you. So you should be familiar with all the names here. Clear? Okay, so if you are done with this one, now acid, base, or salt are everything that is surrounding us. In this world, all the substance may be either acid, either base, or either neutral salts. So now, first, we have to know about the physical properties, which we have discussed. But the second thing, the most important we have to know is about the chemical properties. How are they going to react if we react acid with a metal? If we react a base with a metal? If we react them with a metal carbonate? So we will discuss everything in detail, one by one, clear? So if you're done with this one, I'll rub this. So we are done with physical properties, types of acid. Next topic would be chemical properties of acids. Chemical properties of acid. Now, before I start this one, I will give you 3 steps here. The first one, acids reacting with metal. So what will be the results? Clear? The second one, acids reacting with metal carbonate. The third one, acids reacting with metal oxide. So for chemical properties of acid, we'll study these 3, 1, 2, 3. So one common thing that we will get from here is salt. Clear? One common thing that we will get from here is a salt. Salt. So salt, in all these 3 steps, we are going to get salt. Now, let's take an example. Suppose, just imagine a metal, and you just flush the metal with an acid. What you will get? What you'll observe? You will observe a gas, okay? You will observe a gas, and that gas is hydrogen. So you'll observe a hydrogen gas when you flush the metal with an acid. So for that example, acid, let's use hydrochloric acid, HCl. Now, metal, let's use the common metal that is given in your textbook, that is sodium. Sodium is Na. Sodium. Now, if you just flush this hydrochloric acid in a sodium metal, that means you will get a salt and also you'll observe a gas. There will be an evolution of gas, and that gas is going to be hydrogen. So I've given you a concept here, salt and hydrogen. So what is that salt? See, look here, students, it is NaCl. NaCl. So this is the salt, and what is left? H is left. So H alone, it is hydrogen. So this is the gas. Clear? So when acid reacts with a metal, we will get salt, and also the gas that we'll observe from here is the hydrogen. Now you can try with different metals as well at home. The answer will be the same. You will get salt and hydrogen gas. The second one, acids and metal carbonate, will also give you salt and carbon dioxide. Why I said carbon dioxide here? Because we have carbonate. Since we have carbonate, we will get carbon dioxide and we'll get water. So let's see this one. I'll write below here. So acids, let's use the same one just to make it more simple. Acids, let's use HCl. Now metal carbonate, metal, let's use the same one, that is sodium. And then carbonate means it is always CO3. Okay, students, carbonate means it is always CO3. CO3. Okay, so students, the second one, when acids react with metal carbonate, we will get salt. Salt is the common thing in all the reactions that we're going to get here in the chemical properties of acids. Now, why I said carbon dioxide? Because we are going to react with metal carbonate. Carbonate is there. Carbonate means it is CO3. Okay, students? Carbon dioxide means CO2. And when we say carbonate, it is CO3. So I have metal here, that is sodium carbonate. So we will get a salt. We're going to get the same salt because we're reacting with the same compounds here. So we'll get salt, we'll get carbon dioxide, and then we'll get water. So this is it. We have salt, that is NaCl, we have carbon dioxide and water. So we can balance this one. Okay. So students, please note down this equation. This is the second chemical properties of acid. We have the third one, that is acid, what results we will get if we react acid with metal oxide. That means metal and oxide. So any metal we'll put, and then oxide means oxygen, just one oxygen. So I'll write here, over here, for the third one, that is acids reacting with metal oxide will give salt and water. Clear? So acids here, let's try to use different acids here. Let's use, we often call as king of acids, that is H2SO4. And if you're wondering that what H2SO4 is, you have to go and watch the last previous video because I have already given the name for this H2SO4. Now, metal oxide. Let's use another metal instead of sodium here. Let's use copper. And oxide means just a single oxygen. So we have O. Clear? So now we will get a salt and also we'll get a water. So now see, water we all know is H2O. So this is H2, one O is here. Clear, students? H2O is a water. So we'll take out H2O from here. H2O. So what is left? There we have CuSO4. CuSO4 is a salt. Clear? So students, we are done with all the three chemical properties. In all the three chemical properties of acid, the common thing we are getting to see is we get salt. Now the second thing is when we react, the first one, when we react acid with a metal, we are observing a hydrogen gas. And when we are reacting acid with a metal carbonate, since carbonate is there, we are getting carbon dioxide. What about one O, one oxygen? That joins with the hydrogen over there and we get water. Now the third one, when acid react with metal oxide, just one oxygen, we'll get salt and water. So note down the equation and we'll go to our next topic. Okay, students, our next topic would be physical properties of base and chemical properties of base as well as types of base. So the same concept applies for base. If you have understood all the properties of acid, then the base is very simple for you now. So the same thing goes out for base here. The physical properties, I'll just say it out verbally because I have explained in our last class. Base, bitter in taste, soapy to touch, are those which give hydroxide ion on dissolving with water. So types of base. Types of base. We have a strong base and we have a weak base. So strong base are those which on dissolving with water give large amount of hydroxide ion. Clear? So example would be sodium hydroxide. Example, NaOH. Now if you dissolve this one, you are going to get the breaking down, the same concept like in acid. The breaking of this bond, if we dissolve in water, it will break down to a majority, like 99%, and then we will get a large amount of hydroxide ion. So that means more hydroxide ion, stronger is the base. Now we have weak base, so it's the opposite. Weak base, yes, we'll still get hydroxide ion, but we'll get in limited amount. So weak base are those which on dissolving with water give limited. We get limited amount of hydroxide ion, okay? So example, let's give OH, or we can give that calcium hydroxide, which is the slaked lime, which we have studied in our first chapter. So these are the two types of base, strong base and weak base. So if you are done with this one, we will go and study the chemical properties of base, which is also very important. Okay, now for chemical property of base. Chemical property of base, we have base reacting with metal. So the concept is very similar like acid, right? So base and metal reacting, what we will get as a result. Now, the second one. So this would be chemical properties, okay? Chemical property of bases. Now, the second one, base reacting with non-metal oxide. What we will get? So for chemical properties of base, we'll study these two, that is base reacting with metal and base reacting with non-metal oxide. So base, let's take the common one which we use, that is NaOH. Metal, let's use metal, okay, let's use zinc. So what results we will get? Now here, the same thing applies here. We'll get salt and also we'll get hydrogen. Hydrogen gas will be liberated out. So in exam, they might ask, what is the common thing? What is the common between the acid and base? Then one common thing is, when acid or base they react with metal, we get salt. And the other common thing is, both of them, both the acid and base, when we react them with the metal, we get to see hydrogen gas. So that is the common thing, so you can note down, okay? The common between the acid and base is, if they react with metal, I'm repeating again, they will give us salt and hydrogen gas. So that's the common thing. So we have here sodium hydroxide, which is also considered as the strongest base, and zinc. So if we react this together, we are going to get hydrogen gas, and this one will get sodium zincate. sodium zincate. Sodium zincate. Sodium zincate. Na2ZnO2. Clear? So this is one thing. The concept is very similar to our acid. Now the next one, base reacting with non-metal oxide. So that is, we'll use another base here. Let's use magnesium hydroxide. Clear? And non-metallic oxide, we'll use carbon dioxide because they are saying it's a non-metal. So we're using carbon dioxide. So we will get here one water that is very sure to get from here, H2 and O. So we have, see, if we react base with a non-metal oxide, we'll get salt and water. So water is here. So if we take out water from here, now whatever remaining, that is the salt. Clear? So this is, we have magnesium, and we have this carbon. We have this 2 oxygen here, and then 1 oxygen will be added there, so we'll get magnesium carbonate. So this would be the salt, and this will be the water. So these are the 2 chemical properties of base. Clear? So students, note down the equation. We'll go to our next topic, that is indicator. Clear? Indicator. Okay, students, our next topic is indicator, and this is also very important because these are indicators which help us to identify whether a given substance or given solution is an acid or base by the smell, by the change of color. And this is also very interesting. So the first type of indicator, let's say litmus. Litmus is, you will get in blue color, or in a red color. So from where do we get this litmus? Litmus is, we get from a fungus named lichen, okay? We get from a fungus named lichen, L-I-C-H-E-N. Lichen is where we get litmus. So in the practical lab, we have a litmus paper. Clear? In the practical lab, we have a litmus paper through which we can, through the change of color, we identify whether this is an acid or this is a base. So the first type of litmus, that is blue color, and the second type of litmus, that is red color. So now, if this is a solution, and if you put blue color, if blue changes to red, clear? Keep this in mind. If blue color changes to red color, this litmus paper is a blue color, for the first case. And if the blue color changes to red, that means the given solution is acidic. Okay? Now the second is red color. If the red color changes to blue, then that is a base solution. So this is how we identify whether it is the given solution is an acid or a base by changing its color. So blue changing to red color means it is an acidic solution. Red litmus changing to blue color, it is a base solution. B for blue, B for base. So don't get confused here. B for blue, B for base. So if red is changing to blue color, that is a basic solution. And red color, that is an acid solution. So we have many types of indicator. We will study one by one. But for today, we will just do up till here. So be clear with whatever we have covered, and please continue with your regular studies. Clear, students? See you in the next class.